Hi everyone, today I will explain about particle physics and the 4 fundamental forces that control our universe. All natural processes happens because of interaction between elementary particles. These interactions are explained through the Standard Model, which is the main theory used by scientists to understand the basic building blocks of nature. There are 4 fundamental forces: the strong force, electromagnetic force, weak force, and gravitational force. First, the strong force is the strongest interaction. Its main role is to hold the particle inside the atomic nucleus together, keeping atoms stable. Second, the electromagnetic force acts between charged particles like electrons and protons. It is responsible for electricity, magnetism, and the structure of atoms. Third, the weak force is involved in processes such as nuclear decay. Even though it is weak compared to other forces, it plays an important role in particle transformation and reaction inside stars. Lastly, we have gravity, which controls the interaction between large objects like planets and galaxies. However, gravity is still a mystery because scientists have not yet fully combined it with the Standard Model. Particle physics also studies matter at extremely small scales.
Ever wonder what the universe made of? Particle physics zooms into the absolute smallest scales of reality. Here, tiny particles called quarks, leptons, and bosons interact to build everything we see around us. While our current model explains a lot, major cosmic mysteries remain, like the secrets of dark matter and how gravity fits into the quantum world. Ultimately, by studying the smallest particles, we unlock the secrets of the entire universe.
Hi everyone, today we are going to talk about particle physics and the 4 fundamental forces in our universe: strong force, electromagnetic force, weak force, and gravity. Surprisingly, gravity is actually the weakest of all 4 forces.
That's right, Layla. Scientists are trying to combine these forces into one theory called the theory of everything. They are combined electricity and magnetism, and later included the weak force. The goal is to understand how all forces work together.
And if these forces were even slightly different, the whole universe will be completely different. We might not even see stars, planets, or life. So Fina, let's now talk about the strong forces and its connection to hadrons.
So thanks, Shikin. So actually, hadrons are the particles that interact through very strong forces. So the first one, we call it as meson. So meson only have 2 things, which is quark and also antiquark. While the other one, which is baryons, is contain 3 quarks. So actually, proton is an example of a stable baryon.
But most baryons are actually unstable, right? They don't last very long before they decay into other particles.
Exactly. So baryons decay in less than exponent negative 9 seconds. So through a series of decay, they usually end up producing stable particles like proton and also neutrons. So it's like a particle recycling process.
That's already extremely fast, but some particles are even shorter-lived, like resonant particles.
Yes, resonant particles only exist for around exponent negative 23 seconds, so scientists cannot observe them directly.
So how do scientists know they exist? They study the effect they leave behind. When particles collide, scientists look at the energy pattern of the particles produced. A sudden peak in the graph shows the evidence of a resonance particle.
Actually, by measuring width of these peaks, scientists can even calculate the particle of the lifetime. So these help us understand the hidden world of tiny particles and also how our universe works.
Scuba, scuba, scoop, 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 scoop.